Okay, so in this video we will talk about our ellipse. Now from this we have a horizontal ellipse wherein its major axis is at x-axis, and a vertical ellipse wherein its major axis is at y-axis. Now, what are the important parts of our ellipse? Okay, of course we have our center. So in this example, let be our center h and k will be at 0 0. Okay, so center we have 0 0, or it is, if your center is not at the origin, we may call our center as our h and k. Next is our fixed points, because ellipse is a locus of a point that moves in such a way that the sum of its distances from two fixed point is constant. And what is our fixed point? This is our focus. Okay, this is, let's say this will be our focus, and our focus F is at a distance from its center to C. Okay, so therefore the distance of F to C, or 0, or from the center to F, is C. So from here, so therefore I may call this as C0. Okay, next is our directrix. Our focus is the fixed point, and our directrix is our fixed line. Okay, directrix. Okay, let's say this will be our directrix. Our directrix has a length, or from the center, not length I should say, has a distance from the center equal to A over E. So the distance from the center of our directrix, which is, as I have said, the fixed line in our ellipse, is our A over E. So fixed distance, let's say, let's call this as distance from the center, DC. We have A over E. And what is our E? Our E is the eccentricity of the conic section, which is ellipse. So E is normally, in all conic sections, is C over A. Okay, take note that eccentricity is the measure of how much the deviation of curve has occurred. Okay, next is the length of our major axis. Since I am dealing with the first half of the ellipse, let's call this as our semi-major axis. So the semi-major axis is the length from the center to the point of our vortex. This is our A. So therefore, we may call this A or our semi-major axis as our A0. Okay? Now, from this, we also have our vertex. Our vertex is the point which makes its maximum turn. So this is our vertex. Take note the point where the A, or we have the distance A, is also our vertex. Okay? So vertex is also A0. Now, we also have our minor or semi-minor axis, because as I have said, I am only still considering the half part of the ellipse. So from here, I will have this distance as my minor axis B. Okay? And also, we may say that if we would apply the Pythagorean theorem from this, in which I have a length B and a length C, we may also get our length A, which is also equal to this. So therefore, our A is also equal to B square plus C square, or the square root of our B square plus C square. Okay? Wherein B is the length of our semi-minor axis. Okay? Now, if we will deal with our major axes, so therefore we would use the reflection property of this ellipse, in which we have a vertex, we have a directrix, we have our focus. Also, we have our latus rectum. So, what is the latus rectum? This is our chord through the focus. So, the chord to the focus is, of course, is spiral to our directrix. So, this will be our latus rectum. As you can see, this is from point C at negative y at this point, and in this point we have C at positive y. Okay, next is, as I am saying, is that the reflection property of our ellipse, that it is the same to the other side. Let's call this as our negative side. So if I have a focus here, so I may call this as my negative C0, in which this is where, okay, our value of C is equal to this C, okay, but only considering the negative side. Okay, so yeah, C, negative C0, and also this is our focus. Okay, so negative C0 is our point in our focus, and of course it has also its latus rectum, its vertex, in which this will be our negative A0, and also our minor axis, in which we have our 0, negative B. Now, if The question is about the major axis, so therefore we may say that our major axis, no? No, major axis na lang. So let's call this as our major axis. This is of course the length of from our vertex to, let's call this as vertex to our negative vertex, to our vertex 1. This is our major axis, in which this is equal to 2a. Now, for our minor axis, of course, we'd consider our b. Okay? So we have our b, so therefore this is equal to 2b. Okay? That is a formula for our major and minor axis. Now, the formula for the length of our latus rectum, LR, is just equal to 2b squared all over a. Okay? So this is the different parts of ellipse that may, okay, help you in solving the different equations in our lesson.